Subsequent models have frequently shared symmetry since the invention of the airplane in the early 20th century. However, Robert Thomas Jones defied this rule with NASA AD-1 in 1979. Made of fiberglass and plastic, the odd aircraft had two tiny turbojet engines and could swivel its wings obliquely from 0 to 60 degrees in midair, like a blade on scissors. Aerodynamic efficiency is maximized when lifting wings are used for speed or lift during takeoff and landing. Contemporary airplanes frequently have to select one of these setups. Maximum lift is produced by perpendicular wings, but swept wings forego this in favor of efficiency at supersonic speeds. In 1935, German engineers developed concepts with sweeping wings, but it wasn't until 1942 that Blohm and Voss's Richard Vought produced the design for an oblique wing aircraft. The P-202 jet fighter by Vought was an experimental aircraft to test the Scissor-Wing, which could rotate forward and backward while in flight. Before the Second World War ended in 1945, no test model was ever constructed, and Vought returned to the United States to concentrate on other projects. Aeronautical engineer Robert T. Jones of the National Advisory Committee for Aeronautics Ames Research Center in California created a novel aircraft design that was comparable to Vought's. He thought that oblique wing aircraft might be flown successfully. Although Jones's original and inventive idea was uninfluenced by Germans, he did observe that when planes got more powerful and faster, aerodynamic issues occurred when pilots exceeded Mach 1 speed. He came to the conclusion that airplane performance at high speeds would be enhanced by doing away with the traditional straight airflow perpendicular to the fuselage. To lower drag and boost transonic speeds, Jones suggested designing with an oblique wind pattern. He thought the aircraft could fly more efficiently if the wingtips were moved backward, delaying shock waves generated beyond Mach 1. The idea was dismissed, nonetheless, since it was too difficult and unrealistic. Following his discovery of German concepts, Jones proceeded with his research. These concepts proposed that aircraft with oblique wings may have twice the fuel efficiency of straight-wing designs, meaning that takeoff weight, range, and noise would all be enhanced. Jones also mentioned the propensity of human artifacts to exhibit bilateral symmetry. Subsequently, supersonic wind tunnel testing gained attention, although Jones had originally thought that birds with oblique wings could not fly at supersonic speeds. Oblique wings are more efficient than conventional wings at supersonic speeds, according to studies conducted in 1958 at the Ames Research Center, which is now a division of NASA. Nonetheless, Jones did not pick up his project again until the 1970s, at which point he created an inexpensive experimental aircraft for testing in flight. At less than $250,000, Ames Industrial Company constructed the prototype, known as NASA Ames Dryden 1 or AD-1. Originating from a Boeing oblique wing transport plane, the prototype reached NASA Dryden in February 1979. Despite Jones's study indicated that oblique wing might be stabilized at a particular angle, the AD-1 prototype had a wing that was rotated by an electrically driven gear system located inside the fuselage. Compared to other U.S. fighter aircraft, the jet was modest, with dimensions of little over 38 feet long by 32 feet wide and a weight of 2,100 pounds. Its distinctive appearance was created by its lightweight fiberglass and reinforced plastic construction, and to lessen aerodynamic drag, a fixed tricycle landing gear was installed close to the fuselage. With its squat shape and traditional rudder and horizontal stabilizer, the AD-1 was a prototype aircraft intended for testing the oblique wing design. 220 pounds of static thrust at sea level were produced by its two tiny micro-turbo TRS-18046 turbojet engines. The aircraft was capable of reaching a maximum speed of 200 miles per hour, with a safety restriction of 170 miles per hour. It reached a maximum climb rate of 126 to 138 miles per hour at takeoff, with a speed of 97 miles per hour. The prototype failed to reach supersonic speed. The objectives of the AD-1 program were to compare results with unscaled models from earlier wind tunnel testing, assess the flying characteristics of an oblique wing aircraft, and look into the needs for its control system. The initiative generated enough data on aerodynamics, flying characteristics, and tiny prototypes to demonstrate the possibility for a bigger version. The aircraft was subjected to safety inspections, including loading tests and ground vibration testing prior to flight testing. In order to verify wing deflection and adjust strain gauges for root bending moments under symmetrical loads, wind loading experiments were performed. The wing was 15% stiffer in bending than the design suggested, according to the results. Utilizing an airbag system linked to a hard plate fixed to the wing pivot, the NASA AD-1 was suspended from an I-beam for ground vibration testing. To detect the reactions from different aircraft parts, accelerometers were employed. At the standard perpendicular wing angle of 0 degrees, the aircraft performed its first flight on December 21, 1979, at the Edwards Air Force Base in California. It operated for 79 flights under the command of 17 different pilots, including Fitzhugh L. Fulton and Thomas C. McMurtry, pilots for NASA programs. Early on in the aircraft's life, its overall performance was assessed. On August 7, 1982, the aircraft was finally able to achieve its full 60-degree angle following a series of flying tests done at different sweep angles. John Jones' NASA AD-1 aircraft operated as expected, with a few minor glitches like decreased lateral stability and oscillation at specific angles, especially while moving at full 60 degrees. The majority of pilots concur that the aircraft became unstable over 50 degrees during testing, which was done at a height of 12,500 feet. The aircraft could still be operated effectively in spite of this. However, handling control issues and pitch roll effects made it tough. Warren Hall, a guest pilot, complimented the aircraft's flawless takeoff and landing performance. August 7, 1982, in Oshkosh, Wisconsin, during the Experimental Aircraft Association annual show, was the last flight. The aircraft was returned to NASA Dryden following its public presentation, where it was held until it was put on display at the Hiller Aviation Museum in San Carlos, California. With 79 flights under its belt, the NASA AD-1 proved to be a reliable aircraft. The idea that an aircraft with an unusual layout, such an oblique wing, might outperform a conventional plane at Mach 1 speeds was proven crucially by Jones's groundbreaking design. Because of its unique design elements and rear advancements, the AD-1 became the model for swept wing designs, which are still in use today.